in the body, a lot of reactions are non-spontaneous, and so what happens is that they must be coupled with exergonic reactions to go. So endothermic, exothermic. The corresponding word for Gibbs free energy is endergonic, exergonic, right? And so the only way for these for the endergonic reactions to go is if they're coupled with a very highly exergonic reaction. Okay. Oh yeah, standard free energy, delta G standard. So this is this one assumes 1 molar concentration for reactants and products. Yeah. Okay, and then that's just to keep it standardized across all the different reactions. And then biochemists have their own standard. So that's delta G standard with this apostrophe, and that's 1 molar for all, 1 molar concentration for all reactants and products, except for hydrogen, the hydronium ion. They keep that at a pH of 7 because most things in the body are happening at that pH, right? It wouldn't make sense to have like 1 molar hydrogen. And so this is the formula for your standard delta G. It's negative RT ln of the K of equilibrium. You might remember this from Gen Chem. R is the gas constant, and then T is temperature, and then your K of equilibrium is going to be your concentrations of your products multiplied together over your concentration of your reactants multiplied together, right? So if you have a really big K, that means that a really big K value means that the equilibrium is going to lie on the side of the product, so there's going to be a lot more products than there are reactants. If you've got a really, really small K value, then that means that the equilibrium lies on the reactant side. They're not going to want to change into the products. This denominator is going to be really big. So K equilibrium is the ratio of products to reactants when the system is at equilibrium. Okay, so that's your delta G standard for the equation, and then your delta G. Oh yeah, right. So your delta G standard is what's going to be the spontaneity of your reaction at this standard kind of situation, right? When you have a 1 molar concentration for everything and a pH of 7, but not everything in the body is always going to be at this, lab standard, right? Like 1 molar concentration for everything. That'd be so weird. So in order to find the delta G for your given scenario, the one where the concentrations of different things are changing, you just take your Gibbs standard energy and then you add RT ln Q, right? So it looks really similar to this. You add the RT ln Q, and Q is your once again the concentrations of your products over the concentrations of your reactants, but Q is different because this is going to be specific to what your current concentrations are, whereas K equilibrium is what are the concentrations at equilibrium. Q could happen before equilibrium, it can happen if you push it too far, and so then it also has to come back to equilibrium from the other way. Q is like your current real value, and then the K equilibrium doesn't change because your equilibrium concentrations are always going to be the same, right? And so how far is your Q from your K? Blah, blah, blah. So A, B, C, and D, like I was saying, are the actual concentrations in the cell. K equilibrium is at equilibrium. Q is the ratio of products to reactants in any given setup. Q changes, right? Okay. So if your Q is less than your K, what that means is if you have less products over reactants, then it would be at equilibrium. Then obviously it's going to move further towards the products, right? So your delta G is negative. When your Q is bigger than K, so when you have more products than you should have at equilibrium, it's going to go backwards. It's going to change some of those products to reactants. So delta G is going to be positive. It's no longer spontaneous. It's going to go backwards. And then when Q equals K, then you're just at equilibrium. Delta G can be negative even if the G standard is positive, if Q less than K. Yeah. Okay. So So let's just say that at the standard conditions, it's a non-spontaneous reaction. But then if you have Q less than K, like you have much less products than your reactants, then delta G becomes spontaneous until it reaches equilibrium, basically. So in summary, your delta G is determined by the intrinsic properties of reactants and products, K equilibrium, so this is the standard part, and then you have to account for the concentrations of your actual reactants and products. That's RTL and Q.